April the 7th, 1986, Central City, Kentucky. A crew walks across a stripped coal pit outside Drakesboro toward a shovel 18 million pounds heavy, 20 stories tall. News crews line the rim, along with state and federal officials from the EPA. Nobody has come to watch a machine break down. They have come to watch the Peabody Coal Company bury it. That is the plan, on the record months before this morning. The largest shovel ever built for this part of Kentucky is going into the ground on purpose, exactly where it stands. The Associated Press ran the story that Monday in 5 flat words: Peabody will bury strip mining shovel. But burying a machine this size was never as simple as pushing dirt over it. The state had to sign off. The oil and grease in its lines had to come out, gallon by gallon. The boom and the tracks, hundreds of tons of steel, had to come down. Whatever still had value had to come off and get carried away. And close by, a second machine, smaller than this one but still enormous, stood ready to finish a job this one no longer could. Which leaves the harder question, not whether they buried it, they did. The question is how a machine built to outlast everything around it became something nobody could get rid of any other way. So what actually beat it? A shovel engineered this heavily doesn't usually lose to paperwork and a fuel tank. Before this is over, you'll see why moving it out was worse than burying it, why nobody lined up to buy it, and why the same steel that made it a marvel in 1962 made it a liability by 1986. Here's one thing worth holding on to before the barrage starts. This machine had already tried to destroy itself once, in a structural failure bad enough to stop the whole operation, and it survived that and went back to work. Whatever finally put it in the ground took 25 years to add up. Arithmetic rather than any single decision, and by the spring of 1986, there was only one number left standing. Here is what stood in that pit, in physical terms, before anyone touched it. The shovel weighed 18 million pounds by the manufacturer's own published specifications, though some later accounts rounded up closer to 20. It stood 220 feet tall, roughly the height of a 20-story building, and it could swing its boom out across a working radius of 460 feet, further than the length of a city block. Its bucket held 115 cubic yards in a single bite, close to 200 tons of rock and dirt at once, more than a fully loaded coal truck could carry in one trip. Surviving photographs of the machine at work include, almost as an afterthought, a full-size passenger bus parked near its base for scale, and the bus looks like a toy. Everyone at Sinclair Mine, and most people 50 miles in any direction, called the machine Big Hog. None of that scale required a complicated hand at the controls. Up in the machine's cab, 5 stories above the crawlers, reached by a small electric elevator built into the frame, a single operator ran the entire shovel with 2 hand levers and 2 foot pedals, the same simple layout you'd find in something a fraction of the size. He could take a full bucket, close to 200 tons of rock and dirt, from a dead stop to 25 miles an hour in 8 seconds, and bring it to a complete stop 4 seconds later. The gap between what one pair of hands controlled and what the machine actually weighed is most of the reason this story has anywhere to go. A car this size would be somebody's problem to store in a garage. A machine this size, run by one man from an air-conditioned booth, was a problem an entire company would spend a decade failing to solve. By 1986, Big Hog hadn't moved dirt in earnest for the better part of a year. The coal underneath Sinclair's 5,000 acres was largely gone, stripped, hauled, and burned at the Tennessee Valley Authority's power plant next door, the very plant this shovel had been built specifically to feed. What was left was a company deciding what to do with an idle machine too large to walk away from, sitting in the last open pit of a mine that no longer had a reason to keep digging. The decision Peabody settled on was burial, and the company didn't try to hide it. State reclamation officials signed off. Federal officials from the EPA came to observe. On the day itself, television crews and some of the mine's own workers stood at the rim of the pit to watch. Before any of that, though, came weeks of unglamorous preparation that never made the photograph everyone remembers, The tracks come off first. 8 sets of crawler treads, each riding on alloy steel pads weighing close to 2 tons apiece, with link pins alone running over 100 pounds each. The boom, 210 feet of riveted steel, gets lowered flat rather than left standing at its working angle. And every gallon of hydraulic fluid running through the machine's leveling system, roughly 4,500 gallons of it, has to come out before the state will let a single shovelful of dirt go back over the hull. None of that reads like the plot of a 30-second story. It reads like an industrial operation with its own permits, its own contractors, its own schedule, stretched out over weeks rather than an afternoon. And that's the part the short version leaves out. Somewhere in Kentucky in 1986, a company looked at 18 million pounds of idle machine and decided the cheapest, simplest, most legally defensible thing to do with it was to put it in a hole. Not because burial was easy, because it turned out to be less hard than everything else Peabody had already tried. A shovel this size didn't arrive at Sinclair Mine by accident, and it certainly didn't get built there by accident either. Why moving it out was never a real option in 1986 goes back to how it got in, 24 years earlier. In 1960, 2 years before construction even started, Bucyrus-Erie sent a 14-inch scale model of the machine it was designing to the White House. President Eisenhower accepted the model, then passed it along to the Smithsonian Institution, where it still sits today, in a collection devoted to American industry. The company's own engineers told the president the finished shovel would weigh around 7,000 tons. By the time the real one left the factory floor in South Milwaukee, Wisconsin, it weighed closer to 9,000 tons, 18 million pounds, roughly 2,000 tons past what the original blueprints had promised. Bucyrus-Erie wasn't a company guessing at this kind of work. 6 decades earlier, the firm had supplied 77 of the 102 steam shovels that dug the Panama Canal, and it had spent the decades since building a reputation on machines too large for anyone else in the industry to attempt. What Peabody Coal Company needed from Bucyrus-Erie in 1960 was specific. The Tennessee Valley Authority was building the largest coal-fired power plant in the country a few miles from Drakesboro, Kentucky, and TVA wanted that plant sitting directly on top of the coal field that would feed it, to cut transportation costs to almost nothing. The arrangement worked only if Peabody could strip the ground fast enough to keep the furnaces fed continuously. TVA wasn't building a modest operation either. The plant going up outside Drakesboro was designed, at the time, to be the largest coal-fired power station on Earth, and its appetite for coal was correspondingly enormous. Ordinary shovels, the kind running at every other mine in the county, could not move earth at anywhere near the rate that appetite demanded. So Peabody didn't buy a bigger shovel off a factory floor. It commissioned one that didn't exist yet, built to a scale nobody had attempted before, sized not to what a normal mine needed, but to what one specific power plant, built specifically to be fed by it, was going to demand for the next quarter century. The construction alone tells you what that decision cost. The shovel arrived at the new Sinclair strip mine in more than 300 separate rail cars, carrying roughly 5,000 individual parts, some sections built like battleship plating, with single components running close to 50 tons apiece. New roads had to be cut into the site just to move the pieces from the rail siding to the assembly ground. A dedicated rail spur using custom-built flat cars was laid specifically to bring the largest sections in. None of it could be pre-assembled anywhere else, because no factory floor and no highway in the country could carry a finished machine this size in one piece. It had to be built exactly where it would work, bolted and riveted together over 11 months by a crew that, in more than a few cases, moved straight from construction work into operating the finished machine once it stood up. Even the smallest individual pieces were built at a scale nobody in the county had cast before. The bucket's cutting edge alone, a single lip of specially formulated Bucyrus-Erie steel, 16 feet wide and weighing 20 tons, required the largest foundry pour in the company's history to produce as one continuous piece. The crawlers underneath the machine ran on close to 300 separate alloy pads, each one an individual casting weighing nearly 2 tons, connected by link pins that alone weighed more than 100 pounds apiece. Every one of those parts had existed only as a drawing 18 months earlier. By the time the machine was finished, they were welded and riveted into a single object too large for its own manufacturer to ever fully take apart again without doing, essentially, everything it had just spent nearly a year doing in reverse. That detail is the one worth sitting with, because it's the hinge the rest of this story turns on. Big Hog wasn't delivered to Sinclair Mine the way you'd deliver a truck or a tractor. It was assembled there, piece by piece, permanently married to that one patch of Kentucky ground the way a building is married to its foundation. Reversing that process later, trucking it out, shipping it by rail the way it came in, putting it back together somewhere else, would mean redoing 11 months of specialized heavy construction in reverse, and doing it to a machine already most of the way through its working life. That was true on the shovel's first day of work in 1963. It would still be true 23 years later, when the coal ran out. For those 23 years, none of that mattered, because Big Hog had a job enormous enough to justify its own permanence. The real question is what finally took away the one thing that made staying worth it, not why a machine like this couldn't leave in the first place. From 1963 onward, Big Hog worked close to around the clock, 7 days a week, stripping overburden off coal seams across more than 5,000 acres of Muhlenberg County. On a strong day, it could clear more than 100,000 cubic yards of rock and dirt and expose upward of 14,000 tons of coal underneath, enough, by one contemporary estimate, to heat several thousand homes for an entire season. Over the whole run of the mine, Sinclair supplied close to 80 million tons of coal to the Tennessee Valley Authority's Paradise plant next door, at the time the largest coal-fired power station in the country. For a long stretch of the 1960s and 70s, Muhlenberg County was the top coal-producing county in the entire United States, and Big Hog was the single machine most responsible for that ranking. None of that stripping happened in isolation. Ahead of the shovel, a pair of rotary blast hole drills, themselves billed at the time as the two largest of their kind ever built, bored 15-inch holes 150 feet into solid rock in about 15 minutes apiece, so that blasting crews could loosen the ground before Big Hog ever swung its bucket into it. Behind the shovel came the loaders and the 100-ton coal trucks, the graders keeping the haul roads smooth, the water trucks keeping them from choking everyone in dust. And feeding all of it was a single power cable roughly 1,500 feet long and, by the account of one worker who watched it for years, about as thick around as a man's thigh. As Big Hog crawled forward through a pit, it dragged that cable behind it like a leash, until the machine ran out of slack, and the whole operation paused just long enough to plug into the next portable substation waiting on the rim. Keeping the motors from cooking themselves under that kind of continuous load took 500,000 cubic feet of air a minute, the equivalent output of 500 ordinary household fans, blowing constantly through a machine that never stopped to rest. It also nearly ended early. Surviving photographs from the shovel's working life document a catastrophic failure in its superstructure, the framework carrying the boom and the machinery house, the part of the machine an operator's safety hangs from. Whoever wrote the surviving captions for those photographs didn't record a date, and I'm not going to invent one just to make the story tidier. What the pictures do show is a machine folded and buckled in a way that, at a glance, looks like the end of its working life. Structural steel bent at angles it was never engineered to bend at. The kind of damage that on most machines would be the last photograph anyone ever takes of it. It wasn't. Peabody rebuilt it, piece by damaged piece, and Big Hog went back into the pit not long afterward, carrying on as though the failure had never happened, its record intact except for whatever internal repair log Peabody kept and never made public. This isn't a story that ends with somebody's name carved into a memorial, and I'm not going to pretend otherwise to make it land harder. Fatality records and injury counts specific to Big Hog don't survive in anything I could find, and a channel that spent this entire episode insisting on the difference between documented and invented doesn't get to invent a body count now just because the story would hit differently with one. The danger in this machine's life was slower than a single bad day. It was the fact that something built to survive almost anything mechanical could still, eventually, lose to something that had nothing to do with mechanics at all. By the early 1980s, the coal that had justified all of it, the 11 months of assembly, the rebuilt superstructure, the 2.5 decades of running day and night, was running out. Sinclair Mine had been stripping the same stretch of ground since 1963. There is only so much coal under any given 5,000 acres, however good the shovel digging it up happens to be. By 1985, most of what could be reasonably reached was gone, and Peabody was left holding something that every strip mine eventually produces and almost nothing else in heavy industry does: a machine that hadn't failed, sitting in a pit that had. So now Peabody owned the largest shovel it had ever built, with nowhere left to point it. What happened next is a study in how many reasonable-sounding solutions a company can burn through before the unreasonable one starts looking like the only option left standing. Selling it looks on paper like the obvious answer. Bucyrus-Erie had only ever built 2 machines to this exact design. The model designated the 3850B, and Peabody owned both of them. The other one, nicknamed the River King, was still working a Peabody mine in southern Illinois through the mid-1980s, which meant the entire potential market for a spare 18 million pound stripping shovel amounted, at most, to one company that already owned one and had no need for a second. A buyer wouldn't just be purchasing steel, they'd be inheriting a machine with no factory support left for parts unique to a 2-unit production run. No crew anywhere else in the country trained on its specific quirks, and a purchase price that could never come close to covering what moving and reassembling it would add on top. Nothing in the public record shows Peabody ever seriously shopping Big Hog around to outside buyers, and that gap in the record probably isn't an accident. There was no realistic buyer to shop it to. By the 1980s, American strip mining was already shifting away from these fixed, built-in-place giants and toward smaller, more mobile equipment and walking drag lines that could actually relocate from job to job as a mine's boundaries shifted. The era that had justified building a machine this size, in this way, was closing everywhere across the industry, not just at Sinclair. Moving it to another Peabody property ran into the same wall from a different angle. This was never a machine you drove somewhere. It was a machine you disassembled completely, shipped in hundreds of rail cars, and rebuilt from bare steel over the better part of a year, the exact process that had put it at Sinclair Mine in the first place, run in reverse, at 1980s labor and transport rates, for a piece of equipment already most of the way through its working life. For comparison, Big Hog's smaller cousin Big Brutus, roughly half the weight, had needed 150 rail cars and 52 men working 11 straight months just to go up once, brand new, with a full manufacturer's crew and a fresh set of blueprints. Doing that again, in reverse, on a machine already 20 years old, was never a weekend job or a line item anyone could quietly approve. Nobody at Peabody appears to have seriously pursued it, and the economics answer the question before anyone has to ask it out loud. Scrapping it is the option that sounds, at first, like free money. 18 million pounds of steel sitting in one place looks like a payday to anyone who hasn't priced out what it actually takes to turn a standing machine into scrap. Peabody never published an itemized cost breakdown for Big Hog specifically, and I'm not going to invent one where none exists. But a comparable machine, scrapped elsewhere a decade later, gives you the shape of the problem. When American Electric Power finally scrapped Big Muskie, a Bucyrus-Erie dragline in roughly the same weight class as Big Hog, in 1999, the job took a dedicated demolition contractor months of controlled work, cutting 5-inch steel cables with explosives just to bring the boom down safely. And the recovered scrap sold for around $700,000, a figure that sounds substantial right up until you weigh it against the labor, the cranes, and the months it took to earn it. There's no reason to think cutting up Big Hog in a more rural stretch of Kentucky with far less heavy industry infrastructure nearby would have gone any faster or any cheaper. Whoever took the job would have needed cranes rated for loads most construction sites never see, a crew willing to work outdoors on unstable footing for months, and a buyer for the resulting steel at whatever price the scrap market happened to be paying that year, a market that in the mid-1980s was already depressed by a broader downturn across American heavy industry. Scrapping wasn't free money waiting to be collected. It was a project with its own price tag, its own schedule, and its own risk, and nothing in the record suggests that price tag came out looking favorable next to filling in a hole that was already there. Preservation is the option that exposes how much plain luck decides which giant machines survive and which don't. The same year Big Hog's working life was ending, Bucyrus-Erie's other famous colossus, an even larger sister design called Big Brutus, was being donated by its owner, the Pittsburgh and Midway Coal Mining Company, to become the centerpiece of a new museum in West Mineral, Kansas. Big Brutus found an institution willing to take on the land, the insurance, and the ongoing maintenance of a 20-story steel monument, and it opened to the public in 1985. Nothing in the record shows any comparable effort ever mounted for Big Hog. No museum bid, no preservation society, no local campaign to save it. That absence doesn't prove nobody thought of it. The honest record shows only this: one shovel got a roadside attraction, and its near twin got a pit. Size didn't decide the difference, and neither did how hard either machine had worked. What decided it was whether, at the exact right moment, somebody with land and money and patience happened to be looking. 4 solutions, 4 dead ends, and one option nobody had wanted to reach for first, which was now the only one left standing. Put it back where it came from. Burial solved every problem the other 4 options couldn't. It required no buyer, no rail shipment out, no demolition contractor, no institution willing to take on a permanent liability. Peabody already owned the ground. The pit was already open. All that was left, in theory, was to push the dirt back in. In practice, Kentucky wasn't going to let a coal company drop an intact industrial machine into a hole and call the land reclaimed. By 1986, surface coal mining across the country operated under the Federal Surface Mining Control and Reclamation Act, passed in 1977 specifically because states like Kentucky had spent decades letting mining companies walk away from torn-up ground with almost no consequence, a law written partly in response to exactly the kind of unregulated stripping that had already carved 50,000 acres out of this same county by 1978, according to one contemporary newspaper's own headline, 50,000 acres ruined by strip mining. Under that federal law, and under Kentucky's own division of reclamation, burying industrial equipment doesn't end a company's obligations on its own. It has to account for what's inside the machine first. Peabody applied for state permission to bury Big Hog in place, and by the available record, no objections were raised. But permission came with conditions attached, and the conditions were the entire second half of the job. The company agreed to remove all toxic and hazardous fluids and materials from the shovel before it went into the ground. The Wire story that reported this doesn't itemize exactly what that meant, but the machine's own specifications make a reasonable start of the list. Picture what 4,500 gallons of hydraulic fluid actually looks like, coming out of a machine with no roof over it and no factory floor beneath it, drained and pumped by hand into steel drums, one load at a time, while the shovel that once swung 200 tons in a single motion sits motionless, waiting its turn. Add the lubricant packed into every gear case and bearing housing across 8 sets of crawler treads, the oil circulating through 52 separate electric motors, and whatever sat inside the transformer equipment that stepped the mine's incoming 7,200-volt supply down to something the machine's motors could actually use, and the state's checklist practically wrote itself without anyone needing to spell it out for the newspapers. None of that comes out of a machine this size in an afternoon, draining, flushing, and hauling away thousands of gallons of fluid from a structure with no factory floor and no roof everything done outdoors, by hand and by pump, is its own separate operation, distinct from anything the shovel's original crew had ever been trained to do. The men who had spent decades running Big Hog were, by 1986, effectively decommissioning it instead, learning an entirely different set of tasks on the same machine they'd operated for a living. So burial, the solution that looked on paper like it required nothing but a hole and some dirt, turned out to demand its own permit, its own environmental checklist, and its own specialized labor before a single truckload of earth could go back over the machine. The easiest option on the list was still, in practice, an industrial operation in its own right. It was an operation Peabody was legally and logistically capable of finishing, which was more than could be said for selling, moving, or scrapping. Getting the paperwork and the fluid out solved the legal problem. It didn't answer the harder question of how a company physically retires a machine this size. Kentucky had signed off on burial. Peabody had a pit standing empty and ready. But Big Hog still had one piece of work left in it, and by more than one account, the company let the machine do that work itself before anyone laid a hand on it. On the day itself, by more than one independent local account, Big Hog was given one last task before the burial crew took over. It dug the pit it would be buried in. This isn't a legend passed down second-hand at a bar. A detailed local history of the Sinclair operation, written by someone who worked around the mine, describes the scene plainly, with the news media present, along with a number of the mine's own miners, state and federal officials, and representatives from both the company that built the machine and the company that had run it for 23 years. The shovel faced the new pit and started digging. There was no crowd noise recorded, no speeches, nothing that reads like a ceremony. Just the same crowd and swing motion an operator's hands had run 100,000 times before on ordinary Tuesdays with nobody watching, run one last time in front of cameras instead of nobody at all. Bit by bit, the pit deepened under its own bucket. Then the digging stopped, and the shovel settled into position at the bottom of the hole it had just finished, and the men who had prepared it for this moment stepped back. There's something almost unbearably literal about that sequence, and I'm not going to dress it up further than the facts already do. A machine spends 23 years being paid to remove earth so other people can get at what's underneath it. On its last working day, it removes earth one final time, for no other purpose than to make room for itself. A machine that spent its whole career opening up the ground closed its own story by opening a hole for its own body. What isn't documented, and what I won't pretend to know, is which specific man sat in the operator's cab that day, 5 stories up, riding the elevator built into the machine's own frame the way operators always had, running the same 2-hand levers and 2 foot pedals that had controlled every motion of this machine since 1963. Whoever it was had spent a career learning to move nearly 200 tons of rock through the air with a touch precise enough not to snap a boom cable, and the final assignment asked for exactly that same precision, aimed for the first and only time at a hole meant to swallow the machine he was sitting inside. Settling into the pit it had just dug was the last thing Big Hog accomplished under its own power. Everything that happened to it afterward would be done by other machines and other hands, and none of it would look anything like digging. You cannot lower an intact structure 220 feet tall into open ground and expect a pit to close over it cleanly, even a pit the machine dug for itself. Before Big Hog could disappear, it had to stop looking like a machine at all. With its own digging finished, Big Hog didn't need to move again, so the tracks came off first. 8 separate sets, riding on hundreds of individual alloy steel pads weighing close to 2 tons apiece, with link pins alone running over 100 pounds each. A machine that had walked itself across 5,000 acres for 23 years had made its last move under its own power once it settled into that final pit. The boom came down next, laid flat rather than left standing at its working angle. 210 feet of riveted steel braced during original construction by a pulley rig built specifically to raise that one section into place. A set of pulleys still bolted to the frame decades later, left there because taking them off after the job was done had never been worth the trouble. and whatever still had value came off the machine as well. This is the detail the 1986 Wire stories don't spell out, and it took a different kind of record to find. Components salvaged from Big Hog during its decommissioning were kept as spare parts for its sister machine, the River King, still working Peabody's mine in southern Illinois at the time. Not all of Big Hog went into that pit that spring. Pieces of it kept running for years afterward, inside a different shovel, on a different job, in a different state, doing, in scattered form, some version of the work it had always done, long after the machine that originally carried those parts had gone still. What was left after the tracks, the fluids, and the salvageable components had all come off was a stripped steel hull sitting at the bottom of its own pit, no longer a functioning shovel by any real definition, most of the way to being scrap already, minus the part where anyone had to pay to cut it apart. All that remained was moving the earth back over it, and Big Hog, even reduced this far, was still too large a job for any ordinary piece of mining equipment. Finishing it would take another giant machine, one that was already standing by a few pits over, waiting for exactly this assignment. Peabody didn't need to bring in outside equipment to finish the burial. It already had a machine built for exactly this kind of earth-moving, working a few pits over at the same mine, a Bucyrus-Erie walking dragline, model number 1260. Big by the standards of anywhere else in the country, a boom stretching close to 300 feet, a bucket in the neighborhood of 35 to 40 cubic yards, and, standing next to Big Hog, still only a fraction of the size. At Sinclair Mine, the 1260 had spent years as the reliable second machine, the one that did serious work without ever holding the title of largest anything on the property. Its moment came at the very end, when the mine's actual largest machine could no longer do the job for itself. There's a kind of reversal worth sitting with here, and it's the closest thing this story has to a punchline. For 23 years, Big Hog had been the machine every other piece of equipment served. The loaders, the drills, the 100-ton coal trucks, all of it arranged around keeping the big shovel fed and moving. Now the order flipped. The dragline that had spent its whole career in Big Hog's shadow, never once described in a magazine as the largest anything, was the one still standing, still capable, still throwing earth for a living, while the machine that had defined the entire mine, the one whose name the whole operation was known by for a quarter century, sat motionless in a pit, waiting to be covered by something smaller than itself. Nobody wrote the 1260 up in science and mechanics. On its last working week, it didn't need the coverage. It just needed to keep swinging. There's no documented figure for exactly how many feet of earth went over Big Hog, and I'm not going to repeat the round numbers that circulate online without a source behind them. What the record does support is the shape of the job. A sustained, multi-day operation, the dragline swinging load after load, filling in around the stripped hull first, and then over the top of it, until the shovel, that had once stood taller than a 20-story building, no longer broke the surface of the ground at all. By the time the dragline finished, there was nothing left above grade to photograph. The largest machine Bucyrus-Erie had ever built for Peabody Coal Company was gone from the skyline of Muhlenberg County, not because it failed, and not because anyone destroyed it, but because a smaller machine had spent a few days doing to it exactly what it had spent 25 years doing to the ground around it. The machine went into the ground. The people who had spent careers around it didn't get buried with it, but plenty of them didn't stay in Muhlenberg County either. Coal employment in the county had already been sliding for years before Big Hog's burial, and it kept sliding for decades afterward. By one accounting, the number of working coal miners in the county dropped by roughly 73% between the late 1970s and 2008. A slide that had nothing to do with any single machine and everything to do with the same economics that had made Big Hog obsolete. Cheaper equipment, fewer reserves worth the cost of reaching them, and a national energy market shifting under the industry's feet. By the 2010s, new federal emissions regulations added hundreds of millions of dollars in compliance costs to the Paradise power plant next door, and the Tennessee Valley Authority eventually chose to replace part of its coal-fired capacity with natural gas rather than pay to keep it running clean. The plant Big Hog had been built specifically to feed, was, within a few decades of the shovel's burial, already moving away from coal itself. For the men who built careers around Peabody's operation in Muhlenberg County, the company had, for a long stretch of the 1960s and 70s, meant something close to security, steady union wages, in a region where working the mines was close to the only path to a stable life available to someone without a college degree. That's not an argument that Peabody was a careful steward of the land it mined. By its own regulatory record, it frequently wasn't, cited more than 100 times in the early 1970s alone for failing to meet the state's modest reclamation standards. It's the honest accounting of what the job meant to the people who held it, set against what eventually happened to that job. There's no documented name and no documented fate for the specific man or men who ran Big Hog on its last day, the kind of thread this channel usually tries to hand you by the end. What the record does support is the wider pattern their careers sat inside, an industry that had employed thousands of people around one enormous machine, in one county, for a quarter century, and then, gradually, employed fewer and fewer of them, whether or not that particular machine was still standing to take the blame for it. The machine's appetite had a cost beyond payroll, too, and it's worth stating plainly rather than folding it into the ending as an afterthought. Everything Big Hog and the smaller shovels around it stripped away had to go somewhere, and by 1978, one contemporary estimate put the total damage across Muhlenberg County at roughly 50,000 acres, torn open faster than 1970s reclamation law required anyone to put it back together. A few miles from Sinclair Mine, the small riverside town of Paradise, Kentucky, emptied out over the same years Big Hog was working hardest, its last residence and its post office gone by 1967, its buildings bulldozed not long after. The shovel itself never dug under the town. What displaced Paradise was the power plant it fed and the industry that grew up around feeding that plant, close enough in cause and effect that a well-known song about the town still opens with the largest shovel in the story as its central image. The machine was never the whole reason. It was, for a lot of people living nearby at the time, the most visible one. Above Big Hog today, there's no scar in the landscape marking where a 20-story machine went into the ground. That's not an accident either. It's federal law. Under the same Surface Mining Control and Reclamation Act that had governed the shovel's own burial, Peabody was responsible for reclaiming the barren pits left behind across Sinclair Mine once operations ended, regrading the torn ground, letting vegetation back in, closing the visible wounds a strip mine leaves in its wake. Some of that reclaimed land eventually became something the mine's original planners never intended: wildlife habitat. Starting in the 1980s, Kentucky's Department of Fish and Wildlife Resources began working with Peabody Coal to manage the huge Canada goose populations settling onto the company's former mining land, a partnership that grew over the following decades into the outright purchase of tens of thousands of acres. Today, the former Sinclair strip mine sits inside what's known as the Peabody Wildlife Management Area, nearly 60,000 acres in total across Muhlenberg and neighboring counties. The Kentucky Heritage Land Conservation Fund helped finance the first 34,560 acres of that purchase, and the total footprint has nearly doubled since. Wildlife officers manage it now for hunting, fishing, and birding, and the terrain still gives away what it used to be to anyone who knows what they're looking at. Swampland, folded up against high ridges, water-filled pits where a shovel once stood, the whole landscape rougher and more broken than ordinary farmland ever gets on its own. To a visitor without that history, though, it reads as nothing more unusual than rolling Kentucky woods and wetland, the kind of ground that produces good deer hunting and better duck hunting, with no particular reason to suspect a 20-story machine is resting somewhere underneath it. Big Hog is still down there, by every account that exists. The property isn't open to casual searching, and nobody has published exact coordinates for where, precisely, under several decades of reclaimed Kentucky ground, 18 million pounds of stripped steel hull are sitting. What's documented is simpler than that, and stranger for how plainly it answers the question this whole episode opened with. They buried it on purpose because every other ending had already failed, one at a time, for reasons that had nothing to do with sentiment and everything to do with arithmetic. Too large to move, too specialized to sell, too expensive to cut apart, and too unremarkable in the end, to anyone but the people who'd spent their careers around it, to be worth saving. In 1960, a 14-inch model of this machine sat briefly in the White House before the Smithsonian took custody of it, a company's proudest claim about what it was building rendered small enough to fit on a shelf. 26 years later, the real thing, grown 2,000 tons past what that model had promised, went back into the same Kentucky ground it had spent its whole working life tearing open, not shrunk down for display this time, just quietly made to disappear. So the machine that had spent 23 years pulling Kentucky's earth open went back into a hole shaped, in the end, exactly like the ones it used to dig.